I guess I'm gonna do this again. It's gonna be part 2. In the last version, we built a game prototype and one level. It wasn't anything special. In this one, we'll make it a little bit better, so it's a little bit more fun and things like that. I'll show off some of the other things like camera and all that. So that's where we left off. So where to start next? Let's improve our level editor entities so that we can make them in code. So the one thing I noticed is these flipping things are kind of big. They don't need to be 32 by 32 unless that's just the aesthetic we're going for here. Yeah, it's a tough call. We'll leave them like that for now, but we do need to add some other things like a checkpoint, so that if you have a really big level, you don't have to do it all in one go. It'll resume from where it was left off. So let's add one of those to the scene. Now before I do that, there's other types of layers. So we have the object layer, which is these 32 by 32 things. I'm just going to create a new one of a grid just to show what this is like. Call it borders, and it has 16 by 16, and well, I'll talk about this 32. Let's say grid, and let's make it the red instead, and leave it as bit strings. Alright, so what this borders is now is just a palette you can draw on, and this will get saved. You can right click to erase. This will get saved, so let's save this here as level 2. So if we open that up, refresh it. So open up, this is what you get, the borders. It's a bit string, and so it's 0 if it's not filled and 1 if it is filled. So there's our little square. Each number represents 32 pixels by 32 pixels. And so what you do in the game is you can use, or in the engine, is use a mask, pixel mask of the world. So it'll store this 0 and 1s as a pixels in a bitmap. So it'll be however tall and however wide your world is. And then when you do your collision, it'll actually just pull out if this one here and 32 by 32, or it'll draw a rectangle over it and see if it actually collides with any of the dark pixels, which will be set by the 1 here. So that's a good way to go around doing the borders. In our old way of doing it, we had to draw objects and then resize them like so, and that's just cumbersome and there's going to lead to problems. And you get the same thing done the other way. So let's implement this borders in the actual engine itself. So let's just save that, add a player start just so we can see it if in the game, and the goal is just there. The other thing I remember that we need to check is the player is always starting to the right and down, but if we want to change any of those to say have a level where you start going to the left, I don't know, I don't think that actually happens often, but we should make it a possibility in case we want to do that later. So we'll use this, add a boolean to moves right, default it to true, create a new one, moves down. It's a boolean, default that to true. Remove. So now what we've done is when we place, well, let's open our level. When we place our player, we can actually check off for if it's going to move right or move down. So if we moved left, it would crash into the wall automatically, and it'll have moved down, so it goes. So we need to enable both of those. Alright, so let's save that. This level should be good. In OgmoEditor, the layers, they'll put a little transparency, or they'll become less bold as the layers progress down. You can have multiple layers as you want. We could have another layer just for transition blocks. and things of that nature, but we'll just leave those as entities for now. Alright, so we want to write down, so what else do we want to change in this thing? We probably want to be able to load other levels other than level 1. There's many ways to do this. In my other games, you just automatically move on to the next level. But before we do that, let's add a checkpoint block. You can have more than one. Let's make its minimum size is 16, and we'll make it resizable. And what color should it be? Let's do this yellow. So the idea of the checkpoint is when you go through it, it remembers what directions you had, and then if you crash and it detects that there's no player in the scene, then instead of restarting everything, it just puts you back at where that was. So it shouldn't be too much work to work on. And if there's some noise in the background, that's my dishwasher. Can't not have clean dishes. Alright, so let's make a little more complicated level so it's actually useful. Let's do like this. And we'll move the entity over to the end here. So if you go anywhere in the end zone here, you're finished. Move you there. And let's just make a nice left-right block along the sides here. And let's add some more blocks here. So you have to go in that little corner there. It's not very good either. How about if you just go down too far, you can't get in there. Works for me. And for our checkpoint, we'll just make it so you're there. That's going to be an issue. Feels like it has to go with, by 32. Let's just make everything 32 by 32, because our entity grid is meant to be 32 by 32. Save it. It doesn't change anything really, so no issue here. Like so. So you'll end up moving this way. Let's just make a block. So if you survive that, oh no, that's not how we do blocks anymore. I gotta delete that block so I don't do that anymore. Yeah, so this way you have to go down and then you can hit the checkpoint. While I'm at it, I'm just gonna delete blocks. Yeah. So now we have our level loaded up. We got our checkpoint. So we need to make a checkpoint. It's an entity. What it stores is what directions it was going. So we need the M down and M right. Those are Boolean. We have those. Make some constructors here. They're going to be similar to block, so you know everything should just be inheriting from block, but can't win them all. So a lot of code reuse here. Maybe I'll do that later. But for now, checkpoint. It's pretty standard. Set your thing. We'll change it to be that yellow. And yellow is a color. What do we have here? Checkpoint. We said FFFF8. 4 Fs and an 8. So I'll have our checkpoints be that yellow, and we'll have to make a type for it. So then it sets the type properly, and right now that should draw our checkpoint. But we'll need to add something to say, remember me. So let's do that. Let's do right and then down. So here we'll just store their values. And like so. It's a void function. So now we have a checkpoint where you can say remember me and pass it two booleans and it'll remember those. Might as well have some getters there and set some defaults. So there's our defaults, and then we'll have get right and get down. Not being very nice in documenting these functions, but that doesn't matter. Kind of talking through it right now, so. But if I was actually doing something with this, which I might still, I would add documentation to remember me, because it's kind of not the best name, but the two directions. Should spawn thing. Moving down. Alright, so there's our checkpoint. It'll draw it properly and all that jazz. Interesting, that's a weird bug. Huh, entities have a get right. Going right. Kind of sucks that I have to do that, but we'll, the get right call of an entity will tell you what the x value is of the right side. So it wouldn't let me override that and return a different type. It's alright. So now that we have that, we should add it to our world so that we can load it. Keep going on this if else tree because it's kind of already committed to it. So you have our checkpoint, and it's like every other block, so we'll just grab all the other block stuff. This is where you could use a function maybe, but it's alright. It's a checkpoint now. And so there you go. You gotta do checkpoint added if there's any to be added to. Like so. Now we do have to change something because our blocks are no longer part of the entity layer. They are part of the bit string, which is not under objects. It's under borders. So in order to move on from this, I'm actually going to go and edit level 1 to use the other way, so we can be consistent. See here, borders don't exist anymore, so just quickly sketch this up. There we go. So there's our level. Save that again. We open it up. Now we have our bit string. There's our level. Now we just have to draw it. Yeah, drawing it is going to be more pain, but we can do it. So we could add a block for each, or we could add one block that defines all the red squares in like a graphic list or something. It's gonna get not pretty, but we'll do it. So in AndroidPunk, there's the tile map class thing, and so what that does is you define a large section of entities to render, and it'll generate it all and draw it properly. So we'll use that for this. So block now is going to be every block, not just the one block. Just make a new constructor that uses that way instead. So we don't have any of that, but we'll have pass it the document object. And actually, just a node. So now if you pass it a W3C node, we can get out what the blocks are supposed to look like and do all that with them. So like I said earlier, we can use the tile map for this, or there's the tile image. But tile image doesn't work quite the way we want it. Kind of does it all connected, and just tiles an image, where the tile map is what we want. So actually, that's just that. Can't set the hitbox, we'll set the mask for it later. It's not a shape, it's a tile map. Tile maps want subtextures. That might not work the way I want it to. That is too bad. Oh well, let's... I'm gonna think about this and pause it and return back. Alright, so I thought about it for a little bit there. The tile map's not going to be quite exactly what I need. It's really meant more for if you have like a actual tile to place instead of we have these rectangles that we can place. So instead we're just going to generate a whole bunch of little rectangles and attach them as the graphic for this entity. Not the best, but it'll do. So we'll create an empty graphic list and we'll just append to it for every spot that we see a 1 in the node's bit string. Like always, I'll just refer to my actual OgmoEditor here to just double check that I do it correctly for how to grab out so it grabs the thing. In the other game I have, I call it the grid. So it grabs out all the elements named grid, and there's only one. And so I just loop through all the grids, and I grab the actual grid itself, grab its child, which is the document of the text of this zeros and ones. And I create a new grid, and then I load it from bitstring, which is a part of OgmoEditor, of the AndroidPunk stuff. Now, grid itself, I think, could be actually handy for defining how we want everything to draw as well as load. So I'm just going to take a quick look at that again. So there's a function here for how to read out these bitmap strings and set pixels into or set tiles. I could just copy this out and make it part of a draw type, and that's probably a good way to go. The alternatively is I could just iterate through all the tiles using getTile. That's probably going to be the easiest way to go through it. You can just iterate over however wide and tall it is. Yeah, that's definitely the better way to go about it. So yeah, we'll just create its hit mask, which is called this grid. And that'll be how we do that. So let's go back to our block. So here we are, we have our graphic list. But first, let's make a grid. And as a width and height, which is going to be the width and height of our level. So I can't really do it here unless we pass in how wide it's supposed to be. I should be able to learn that from the actual string itself. It's weird. How do I do this over here? I load from the level size. Oh, we'll just pass it in. Give her width and height, and tile width and height, which we're going to set to 32 because that's what we have set it to in our other world. So now we have that. We can load from string. I believe we use the default separators, which is, no, we do not. So in it, we're going to load from a string. The column separator is nothing, and the row separator is a new line. That's just the default way of OgmoEditor dumping it out. Let's just double check that that's how this works. Yep. And so just might as well copy this out because it's going to be very much the same. So instead of that, we have node, but the node is that node. So node, you get the first child, and the child is the text node, which contains our level. So grid bitstring, and then we just iterate through the width of the grid itself. Okay, columns. This is going to save us in the end, but whoops, this is columns, and the other one's rows. So now if there is a tile there, a column, row. So if the tile value is 1, then we want to draw a 32 by 32 rectangle at that spot. So we create a new shape. At x times 32 and y times 32, and they're 32 wide. Set the color to be this red. Color's red, and then we add it to the list. So that'll go through, and then you can set the mask to the grid. And apparently, oh, it's Boolean, so you can just leave it like that. Alright, so there, that if it's set in our grid, it'll draw a rectangle there. So now this constructor actually has to be passed the actual build blocks from grid node. Grid node and width of level, height of level. This actually creates a bitmap, the size of the level divided by 32, and so it stores it pretty nicely, and it just is pretty, it simplifies collision and everything, so it'll be nice to have. So let's add that to our world so it actually loads it properly. So now you're no longer in objects, right? We're in, we have blocks of their own thing. So we can get a node list of them. What do we called it? The borders. Yeah, I might change that. That's a stupid name. I'm just going to change it to the blocks layer. The block layer. There we go. Now just open up the two levels. A cool thing with OgmoEditor, you open more than one level at a time. Now we edit the block layer. Just quick, like so. Clean it up, save it. Go here, do the same. Same level, save it. So now we have our block layer and our objects layer. So if we update this, it's now our block layer. Similar with level 2, it's our block layer. Let's go back. Not the engine, I want the Swift world. Oh, there we go. So now we have our node list, our block list. Now because getElements by tag name returns the list of things with that thing, and we just want the first one, so we just check if the count of it is greater than. Oh, there's a size on here somewhere. I thought. Where do I just not see it? Get length. There we go. It's greater than 0. Then we get our node grid, our node block grid. It's the block list item, the first item. So now that points to the actual first item, which will be this one, this tag here in XML. And then we can grab its first child, which is this. So that'll be done in the block itself. So don't have to worry too much about that. So let's just create a new block out of it. Given a node, which is the block grid, and the width and height. So now our blocks will be loaded in, hopefully, so we can get rid of this now. Alright. The block is still tagged the same way. Its hit mask is now different, because it'll be based on whatever bits of the thing are 1. It knows that every block is or every one is 32 pixels wide, and all that good stuff. Cool. So that should run. And oh, I have my phone plugged in still. Just unplug that for the rest of this. So this is going to load that first level that we had. And if we have blocks around it and we can crash into them, then we know that it works. And it doesn't. That's great. I don't know if I set the graphic, but and you can't collide into them either. So not exactly what we wanted. Let's take a look at what changed. So we go to add that block. Might as well print a log thing saying add the block. New block. And it has no x and y set to it. It kind of just exists at 0, 0. Oh yeah, I did not set the graphic, which is too bad. Graphic. Big list. Set the mask. Now I really should have collided into this mask. Unless this didn't actually have the first child. So let's log something that says loading bit string. Load our log. Add our tag. That we can use to load things. There we go. So we should see loading bit string and it drawing things. That is in case this load bit string actually worked. Hopefully I remember to pause during these load times. So there we go, it's drawing it properly again, but we still can't crash into it, so that means my mask part isn't working properly. Too bad. Let's make sure we can fix that. So we're just going to take a peek at how I do it over here, just make sure I didn't do anything wrong. Set mask of that bit string. That should be all you need to do. Curious. I do not set the type. There you go. That's it right there. As you can see, it says loading bit string. So everything's good, and you get your new block. So now that it has a type, we're good to go. It should actually collide with things as the player sees. So let that load, and while it's loading we can move on to the next thing, which was checkpoints. We never actually did add checkpoints. So a thing when you hit the checkpoint, you kind of want to put yourself in the middle of it, or you can put where you came into it, but that might put you in some awkward positions which you can't get out of. So we have to be careful of that and make a decision and stick with it. I'm going to go with when you go through it, you spawn in the middle of the checkpoint. So then you can do things. I'm just going to make sure, yeah, crashes. Yeah, see that? Awesome. So there, we've replaced blocks with our bit string, and now it's easier to draw levels and things like that. Entities and still have to be resized. But so to show what I mean with level 2 with this checkpoint here, let's actually go like that. We grab our checkpoint here, and we resize it, and we move it back. So now if you make it there, you actually spawn in the middle of it, so you'll spawn there, and that'll be a lot easier to deal with. Now, the player itself can grab it out of the checkpoint just by having it know that entity. So instead of colliding and removing, we can just move ourselves to the last known checkpoint and just store the last known checkpoint as the start square. So let's alright. This is probably going to be a terrible way of doing it, but I'm going to do it. Spawn location or something. And so we just set that to be wherever you spawned. So there we go. I have to add a thing, so the Control-Shift-O import there. And so we want to say if we go through a checkpoint, we can just store the last checkpoint as well. which is going to be just null at the start. I'm going to do something crazy, and actually just wherever you spawn, you add a checkpoint. But you don't set it visible. So you just start in a checkpoint. It's a quick way of doing this, I guess. So we make a new checkpoint. Spam last checkpoint. And since we didn't actually add it to the world, it should be all fine. So we set it to our X, our Y. Now, since our characters draw from the center, and we put it in the center of a thing, we can actually just minus 16 from our X to get the top left corner. And now for width and height, be 32, 32. So now we have a checkpoint at the start that we set to be our last checkpoint. And now I don't really need this part here, because we'll get that from the last checkpoint. Now it's never been added to the actual world, so you can't collide with it, but we know where you spawn, and that's all that matters. And then if you ever hit a checkpoint, you can update this, and then this will get freed eventually. So if we ever collide with a block type, where do we do that? Block type. Instead of setting the world to none, we set our X and Y to, or our MX and Y to be where the spawn location is, so the center of the spawn checkpoint. And whichever direction we set ourselves to, which I should do up here with these start down, start right things. So, and last checkpoint, remember me, I'm right, I'm down. So now the checkpoint remembers which way we can go. We just have to change our values back to it. And then everything should be good from that point on. Now that's not actually right. You want to add half the width and half the height of these things as well, which will actually put us in the middle of the checkpoint, so we don't need to have this at all, because that's what that was doing before. Height divided by 2. So that'll put you right in the checkpoint. If you're already in a checkpoint and you spawn in it, you'll just set yourself to that checkpoint every frame you're in there. That's not a problem. Shouldn't be, but alright then. Now, if we collide with a checkpoint type, then we collide with it. We actually want to store out, so we're going to set e equals. Reuse this e here, so you can just set the last checkpoint to that, and that should be all we need to do. So if you crash, you'll get reset into it, and if you ever touch a checkpoint, it sets that to be your last checkpoint. Looks good to me. That should run. In order to test this, we can actually just hardcode ourselves to start level 2 instead of level 1, since level 1 has no checkpoints. So a reminder, level 2, you have to start and go down, so you can hit this, and then you can bounce off and go down and get in there. We can make it more complicated later, but that'll do for now. So here's our level 2. Let's just crash, so we start at the start again. And if we hit the checkpoint, I'm going to have to try and make myself crash here. And there. Oh, I did not reset my directions I was going. Alright, so let's fix that up. That's in the player. Instead of just setting your position back to a checkpoint when you collide, you also have to set your M right and M down. And there we go. That should be everything. This is actually turning out pretty well. It's been another 40 minutes, but our levels can be made a lot easier. We have checkpoints. Next, I think we'll go into cameras, so you can have worlds that are bigger than just the screen size. Let's make sure we can save it there and crash ourselves and continue going the way we thought we would be going. So I should crash here if I go in. There you go. Just test to make sure everything's still good. Now I'm going to crash going straight down. Yeah, so good. Bam, crash. Alright, so checkpoints. Just make sure the UN works. And you win. Alright, so let's talk about camera. The camera position, you tell it the top left corner of a map of where you want to be. So right now, since our levels are the size of our screen here, you can't really see there's this redness around the outline that defines what the camera size actually is. So let's make a new level, level 3. Now level 3 is going to be a little bit bigger. Edit it like this. Let's make it a long one. So as you see OgmoEditor, you can make levels that are bigger. This shows you what you can see in the first camera view. If you were just looking at it, just add some blocks. This is where not having to worry about entities is going to make it a lot easier. Let's just end over here somewhere. You always want to include your main area there. Let's set the player start over here. Let's make it so you have to go down, then you can like bounce up or something. Not quite like that. Yeah, something like this. So you come down, you go over here, both reflect there, then we'll have to reflect there, and then we can go this way, and then we have to reflect something off the top. So we'll actually give us some more room here. Yeah, at which point you will have to reflect off something here, and then you can go down and hit the goal. Let's just like clean this up a little bit here. Like so. Let's drop some of these objects down now. You can hold space to move around the thing as if you click down. Pretty handy. So our goal is this. So we have to have a left-right block right there. We have to have an up-down block right there. Might as well add a block so you can't go there. And then we need to have a left-right block up here as well. Remember, they can only go downwards, so like that. So you hit, you bounce, you hit. Otherwise, you can just hit this one, but if you miss it and hit this one, you have to hit that one. So that makes it a little more multiple ways to go around it, which is fun. There's no reason why you shouldn't need to do that. And I'll make this a little bit harder. Move this over here. Remove that block. add blocks. So you have to hit this one little block here. It's going to be quite difficult. And you can't just hold down, you have to adjust to go back down over here. Yeah, that's pretty good. Alternatively, I could put the goal over here, and you'd have to bounce off something else over here. But let's just keep it like this for now, because we have to discuss a lot of things like camera and all that jazz. So there's many ways to do camera. You can center yourself on it. It looks alright. As you move, you'll still be centered in it, so the camera will kind of follow you. So you go boom, boom. So this will just simulate what it kind of looks like. Boom, boom, boom. See that one there? You go boom, and then you go down. So that's what camera I think we'll implement. Let's just see how it looks. If we wanted to, we could fill this up, but that'll just add extra drawing, and it doesn't add anything to our level thing here. So, like so. Let's just leave it there. Let's add a checkpoints. You gotta do this all in one go. So if you load this level right now, the thing will come over here, and as soon as it gets here, you won't be able to see what's happening anymore. So that's what we're going to change. You can do this in multiple ways. You can create an entity that'll update the camera location, or you can just have the player itself update the camera location, so it's centered in the view. That's probably the way we'll go about it. We don't have any. You don't have to zoom out or make sure anything else is in screen. You just have to make sure you're in the screen. So after you've updated, you make sure that you recenter the screen. So FP has the camera object, and so basically it has an X and Y, and all you have to do is make sure that that is the width of this, half the width away from you, and half the width or half the height away from you. So it's your X value minus half width. Now we'll have to cast that into an integer, like so, and then we do the same for the Y. It's half height. So that should work. Let's just see what it looks like in our smaller level, the level 2 that we had there. Now internally all the camera does is offset all your drawing. And there you go, camera follow. So that's basically what we have. So now we have camera and levels that can be pretty big. So that's pretty neat. Before I go on to anything else, I just want to show off a little AndroidPunk feature here. So if you go to your activity, you have this debug statement, which you can turn on. You have to import FP. Done. Let's run that, and I'll just show you. Since this is in the emulator again, it kind of looks like it's choppy and all that. But this should render 60 frames per second on any device, including like the G1, the original Android phone. But what you get is you get this little FPS counter in the top right, and after a couple frames it'll update and tells you how long it took to render, how long it took to update all the positions. Worth noting that the update, which includes checking all the collision and stuff like that, doesn't even take a millisecond on the actual emulator. It's just the rendering, which is done through software, so it's expected to be slow. So everything seems good. Now instead of just dying, let's load the next level. I mean, when we hit the goal, and instead of just stopping everything, let's load the next level. So we'll have to know what levels are available. So normally with our Swift world, we just create one. So there's another thing that we can add, is the data. You can get the data, and you can get values out of it, and put values into it. So I'm going to get the int of, make a key for it. Data level. So I'll just set that to level. And here you can actually define a default value, so if they haven't seen it before, you can tell them load the first level. I'm just going to one index here. It's kind of weird, but whatever. And so now we have a level. Let's pass that into our world, so it knows what level to load instead of just loading nothing. Store that level for when we get actually added to the scene to start loading it. And remove these things that are no longer used. We don't have to worry about restarting the player because the player restarts itself. At this point I'm just going to get rid of this old code. Now instead of loading blank, we can just load what we need. There's multiple ways to do this to make sure that the file actually exists. Before you load it, I think getXML will actually throw an error if you don't, or it'll return null if it's not an actual level. This is useful if you want to wrap around and always just jump to the next level after you've done. So instead of goal saying you win, you could actually just start loading the next level automatically. So let's use the format to levels, level 0 indexed 2D.oel. If you don't know string format, it's pretty handy. Standard C format strings. So what it's going to do is input in whatever I pass into this part here, which is going to be the level we're loading. It'll put it here with a 0 in front of it, and it'll always be 2 digits big. And a D means a decimal number, so it's going to put a decimal number there. And now instead of loading level 2, we load level file name. So the way this will work is it'll actually load level 1 first, because that's where our engine says to do. It says get the data out of data level. If it doesn't exist, load level 1. So let's make sure that that works, and it's loading level 1. Now what is it complaining here? Oh. Yeah, I'm gonna ignore this because I'm not gonna have to worry with locales. I know exactly. So that's an Android thing that they added to make sure that your stuff is good. Let's clear all the markers. So now if we load our actual thing, see we're back on level 1, and when we crash we start at the checkpoint again. So everything seems to work. I still have the debug information there. I should get rid of that. It updates every once in a while, so it doesn't affect too much of the thing. It does skew the render time, but yeah, so when you win, we should just wait a bit and then actually just start the next level. So I recently added a task timer, which is just a little after a certain time, just do something else, and we can add that to say load the next level. Now to do that, we might want to have a way to get what the current level is. So we can just do that by making a static variable here. And so this is kind of dangerous. It usually causes problems and things like that. But it's going to be really easy and nice to be able to, you know what, that's totally unnecessary. Since we have to update our stored information as well, why bother doing this? Yeah, well, that was a waste of time to go. Every time the engine starts, it's going to figure out what level it was last at. So all we have to do is set what that level is, or find out what that level is, and then add 1 to it when you hit the goal after a certain amount of time. But first things you can do is just say you get your data level, default to 1. So you have to take it from the Swift engine, like so, and then you +1 to that. Data.get data put or edit put int and Swift engine data level, and our value is going to be whatever the last thing was +1. Kind of a complicated thing there, but whatever. We'll remove ourselves still from the level, and then after a second we launch the next level. Now to do this, we can do the task timer way. It's a good way to do things. Get rid of that. So it's going to be null originally, and if it's ever not null, we want to step it. So the task timer is just a thing that happened often when I was making a game, is you want certain things to happen after a certain amount of time, and you want it to continue to happen as long as time is passing, or you want to say this is a timer for 3 seconds, and it starts at 1 second and a half. So after 1 second and a half, run this function, and then if you keep giving it time, it'll keep running this after 3 seconds after that. It was useful in like animating things and all that. We'll get into other animations. There's a whole, they call it a tweening library in FlashPunk and AndroidPunk. Makes things easier. But first things, so if we have this timer set, then all you have to do is say step it. Step, and you have to tell it how long it has passed. So you could actually accelerate time if you wanted it there. Not equal null. And then whenever it passes whatever threshold you pass into it, which we can do here. So it's a task timer. And so you tell it how long. Come on. Like so. And so we said 1 second. Let's make it 2. And then on time up function. So here you can just run whatever function you want. It's your standard callback. Implements runnable. So here we want to set ourselves to the next world, next level. So it's a new Swift world. And we want to get our last level. So we've already set it to the next level, so that whatever this will be whatever the next level was set to. Oh, what is it complaining about? There. It wasn't imported, so we'll just make it off of there. And then so now when you collide with the goal, it starts up this timer. But it removes the thing from the world, so it no longer gets updates. It's not exactly what we wanted. This timer idea might not work out the way I planned it here. We could set a thing to say that if the timer's set, then we don't move at all. That's one way of doing it. Or we just say that we're in the goal, we don't move. You can do some sort of other animations as well that way. So why not? We could also just say that if you collide with the goal, then you move back to where you were. I like that too. So there's multiple ways to do this, and let's see. Let's just create a boolean for if we're in the goal. In goal. So if we hit the goal, then we don't update ourselves. we'll stay wherever we are and we'll move. Which means we'll constantly collide with the goal. Move this to the start of the thing. And just do some cleanup here just so things make sense. Now if you're not in the goal, you want to update your position. If you are in the goal, every time you update your position, you don't need to do any more checking, you're done. So you update position, which also updates camera, and then we don't have to check anything else because everything should have been happened. Now just make sure to set that you're in the goal. And also make sure that you're not in the goal to begin with. Like so. So now whenever you hit the goal, it should add 1 to the level, wait 2 seconds, and then set yourself to the next level. So let's see if this works. Here we go. We still have that nice camera centering. Let's just pass this level so we can see ourselves go to the next level. I think I still have the code that removes yourself from the game. So it's not going to do what I wanted. Dang. So just remove the removing yourself. That'll make things better. That should be loaded now. And then when we hit this, it should still be there. We stop moving. And then, oh look at that, that's weird. Oh, it'll load the same level. Whoa. That's also a buggy there. Not supposed to be able to hit that. So you hit the win. Why does it change your direction? Ugh, it's gonna be a tricky one. Sit you're in the goal. The only way for it to rotate left and right, or change directions like that, would be for it to hit a checkpoint or hit a switch block. Definitely not hitting a switch block, because there's none there, but there's a thing called commit that actually sends it back to be saved. That's one thing. Let's get that out of the way. Now, why does it rotate the thing or change your directions? That I do not know. It could be that it's checking to see if you hit a block because it uses that value. I don't check it soon enough. I could just say if you're in the goal after. Yeah, you're in the goal, you're done there. And everything else can be the same. Which means you update your camera position, you update your XY, and all that. Alright, let's run that this time now. So it should change our level. It should not change any of the directions you're pointing. I believe I put it after the hide lines, or before the hide lines is still there, but there's nothing to should change your directions. Gotta hit it better. So that one bug where I was hitting off of that is caused by your width and height not being equal. So when you rotate, you actually jump into this left-right one. It hides all your lines, you've hit the end. 2 seconds pass, we're on the next level. Alright, so that's exactly as we expected. Let's see if we hit our third level. If I finish this level. I should probably fix the bug where if you tap it on the thing, but we'll leave that for another time right now. Cool. I like the actual disabling the lines when you win. Keeps it clean. So here's our crazy huge level. Now this is running at half speed of what it would actually be running at. We can make something later to say you go faster the longer you're in the level. I don't know. We'll think of something to make it more challenging. I like challenging. So I'm going to do it the way that if you accidentally hit this one, you have to hit that one. Let's see if I can do it. I might set a checkpoint over there just so you don't have to go through that long thing all over again. So we hit there, go up again, we go across. I'm going to see about changing myself to OpenGL accelerated instead of software, so this will be faster, but I'll do that when I pause it in a second. Alright, hit that, start coming down, and I move and I hit the goal. Now there's going to be a bug where it tries to launch something, so it probably is going to crash here, so beware. And it didn't even say you win. That's interesting. I would have expected it to say you win. Because it did update the level, so now actually every time I start and there's no level 4, it's going to crash. And this is where we will want to actually do some error checking in when we generate the world to say if it exists. So what we're going to do is actually pull out the object first, and then if it's not equal to null, then we load our level. Otherwise, we can just set ourselves to level 1, or return to level 1 just so we can keep it from crashing. So we get our data, you get an edit, or for it you put int to the Swift engine, the data level, we put 1 back in there, and then let's load level 1. And we'll just copy this in there. We'll just assume that it's always going to be there. Like so. Double load, it's not going to help anything. So there, we set our level back to 1. There's other ways to do this, like if you are playing a level, you can then say that you save that as your level. Whichever you find easier is better. I need more brackets. Parentheses. So there, if we go off the level, or if the level doesn't exist, we go there. Let's just double check what error we got. I think it's a null pointer exception, yeah. So it's in load 37, which was this load here. When you pass yeah, so it was this here that was causing it to null pointer exception. So if it is null, then we load to the first level. Just make sure that it should load the first level next time we launch it. And then there we have camera controls and some little more advanced OgmoEditor stuff. It's been an hour and 10 minutes. I'll probably call it a video and when this loads up and runs. Level 1. Crash. Yeah. Yeah, that bug of hitting that and being trapped there isn't really that bad, because if it's going to reflect around the direction you didn't want to go. So you win. Huh, start the same level again. Interesting. Make sure that doesn't happen again. Huh. Yeah, didn't commit. So it keeps trying to load level 4. Doesn't exist. Launches level 1. Yeah. That's gonna get me every time for a while. But this lets you save persistent data like high scores, usernames, other things. It uses the Android shared preferences stuff. Yeah, so you can store what level you were at, high scores, all the good stuff that makes a game fun. So you can store how long it took you to solve a level, or how many deaths you had. Anything of those natures that you want to actually store between runs of the game. Just gonna run through the first 2 levels here and then show the third one. And we bounce back. But now, yeah, you win. This right here is pretty much a game that could probably be shipped. Running on a phone, it runs about twice as fast. Maybe you want to tweak how fast things are. Maybe you want to add high scores or something. Maybe you just want to make a whole ton of levels and try and do crazy things. The original game has portals that you can go through, where if you go through it to the right, you come out of the other side of it. Things like that. There's also the crazy move or in circles if you run through this line. We're not going to do any of that. We'll just keep it simple for these sort of demo stuff. But I might make a few games and just give it to some people, or send out the APK so people can try it out and see that it works and doesn't run like this because it's in an emulator. So hope you enjoyed learning a little bit more about OgmoEditor with grids, and we're okay. Well, it still doesn't say you win. It's not cool. I like to see the you win. Yeah, alright. Thanks for watching. Again, hope you find this stuff interesting. Maybe till next time.